In early 2026, Tesla halted the production of its longest-running vehicles. On a single earnings call, the company announced it was discontinuing the Model S and Model X, clearing the Fremont assembly lines to build something else: humanoid robots. This wasn't a small pilot program. Tesla is aiming to manufacture 1 million general-purpose humanoids every single year, machines designed to walk, lift, and work in any environment. Elon Musk is betting his manufacturing empire on this transition, projecting robots capable of replacing human labor will roll off these lines in massive volumes. The hardware economics driving this pivot are stark. In just 3 years, the cost of a capable humanoid robot fell 95%, dropping from $150,000 to under $5,000. Analysts identify this exact moment as mass production year zero. This collapse in production costs has triggered a global arms race for the next decade of physical labor, and the competition for market dominance is already underway. The United States is approaching this market with a specific strategy, focusing on premium artificial intelligence and high-margin industrial contracts to differentiate its hardware. Tesla's specific advantage is the data flywheel. Every deployed robot collects real-world operational data, fed back to train the central neural network for every other unit. By compounding this, Tesla builds the dominant operating system for physical labor, an architecture others must eventually license. Other major American developers are validating this approach. Companies like Figure AI and Boston Dynamics have already demonstrated their robots successfully running full autonomous 8-hour shifts on factory floors. These machines are integrating directly into real production environments today, including heavy payload partnerships between Apptronik and automotive giants like Mercedes-Benz. That cost compression is supported by government subsidies and a localized supply chain, allowing factories to iterate from early prototype to mass production in a fraction of the time required elsewhere. The sheer volume of output is reflected in the intellectual property data. Over the last 5 years, China has filed 5 times as many humanoid robot patents as the United States. This is the same industrial strategy China used to secure the global supply chains for solar panels and electric vehicles over the last decade. Because these two approaches are so different, the global robotics market is fracturing into 2 distinct, incompatible ecosystems, built on separate software and components. By pushing the limits of cost efficiency, China is positioning its hardware to be the default choice for the rest of the world's physical labor needs. While corporations battle for market share, the consequences of this transition will be felt most by the human workforce. Economists call this the squeeze, the simultaneous automation of white-collar knowledge work and blue-collar physical labor. Historically, automation created jobs elsewhere, but this rapid dual transition means there is no obvious industry where millions of displaced workers can flow. The shift is already being scheduled. Foxconn, a company with roughly 1 million employees, has committed to replacing human assembly workers with tens of thousands of robots by 2028. When massive employers move from testing prototypes to setting deployment deadlines, automating human labor moves from theory to a logistics plan. Major financial institutions are already modeling the impact of this transition on the global economy. Investment banks like Morgan Stanley have projected a $5 trillion global addressable market for humanoid robots by the year 2050. Regardless of which corporate ecosystem or which superpower wins this automation war, the machines are moving from the design phase to the assembly line, and the human worker stands at the center of that transition.